Hello everyone, how are you all? So, I hope all of you enjoyed your holidays and also utilized your time during these holidays regarding to your difficult subjects. Whatever, welcome back to our regular works. Welcome again to my channel Hari PS videos. Thank you for my subscribers and viewers, and as usual I request if your friends who are reading in various we are studying in various schools, please share my channel and ask them to watch the videos, and if they like, ask them to subscribe and share with others also, and please give a like to my videos if you like, and give a comment about the explanation about the concept, whatever. Okay, then most of the viewers are watching the recently uploaded videos, but not watching the previous videos which are uploaded previously. So once again I am requesting you, as per the topic which is going in your school, based on you have to watch the videos. Please give a like and make a comment, because your likings and your comments give your likes and your comments make me happy, and I will try to improve myself during my explanation and while explaining the concept. So please watch the videos, subscribe if you did not subscribe, share the channel with your friends or the relatives, give a like and make a comment, right? So let's start our session. Previously we discussed hydrocarbons, different kinds of hydrocarbons, and different kinds of hydrocarbons, different types: alkanes, alkenes, alkynes, then homologous series, isomerism, functional groups, then carbon and its versatile characteristics, and allotrope forms of carbon, and covalent bonds, three types of covalent bonds, and three types of covalent bonds in the sense I re-uploaded the videos. Then functional groups, isomerism, homologous series, and we discussed how we have given the names for alkanes, alkenes and alkynes. So we discussed about acyclic hydrocarbons. Acyclic hydrocarbons. Acyclic hydrocarbons in the sense, so the hydrocarbons have no closed structures or the ringed structures. So different kinds, acyclic hydrocarbons and cyclic hydrocarbons. So I already gave you I already give a chart form, a flow chart. Then let us discuss today cyclic hydrocarbons. Cyclic hydrocarbons. From the chapter carbon and its compounds. Today our topic cyclic hydrocarbons or regular hydrocarbons. Cyclic hydrocarbons. So what are hydrocarbons? The compounds formed by only carbon and hydrogen. Formed by carbon and hydrogen. Such compounds are called hydrocarbons. Hydrocarbons. In that we discussed acyclic hydrocarbons means have no ringed structures or closed structures. We discuss long chains or parallel chains. Then here the cyclic hydrocarbons are also two types. One is saturated cyclic hydrocarbons. Saturated cyclic hydrocarbons. Then unsaturated cyclic hydrocarbons. Saturated hydrocarbons and unsaturated hydrocarbons. Saturated hydrocarbons in the sense between the carbon atom there is only single bond. Then at least one double bond or triple bond between the two carbon atoms in a compound, then we can say that unsaturated hydrocarbons. Saturated cyclic hydrocarbons. Cyclic hydrocarbons in the sense they have closed structures. Right? So the form, for example, saturated cyclic hydrocarbons. Example for the saturated hydrocarbons we have taken first of all. So 1, 2, 3, 4. How many carbons? 4 carbons. So between the carbon and carbon, how many bonds are there? Single bond. 1, 2, 3, 4. 4 single bonds. So this type of hydrocarbons are called cyclic hydrocarbons or ringed hydrocarbons or closed hydrocarbons. So here let us check the tetravalency of carbon. 1, 2, 1, 2, 1, 2, 1, 2, 3, 2 are there. So hydrogen, then here hydrogen, 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 hydrogen and hydrogen. Now carbon valency 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So tetravalency satisfied. Tetravalency satisfied. So how many carbons are there? 4 carbons. So 4 carbons, then we have to say bute. You can say that bute. So all single bonds property, then it is a butane. in a hydrocarbon has a single bond between the carbon and carbon atom, between the carbon and the carbon atoms. So we can consider as saturated hydrocarbons. These saturated hydrocarbons, these saturated hydrocarbons are 4 carbons consist. So it is an example for alkane, cycloalkane, cycloalkane. So butane. So the section is closed or ring carbon. Then we can say that cyclobutane, cyclobutane, because it has 4 carbon atoms. It has 4 carbon atoms. With 2 carbon atoms, we cannot form a ring or a closed section. If it is 3 carbon atoms, 1, 2, 3, 1, 2. Here 1, 2. Here 1, 2, 1, 2. So hydrogen, 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 and hydrogen. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right? So cyclic, cyclo, ring. How many carbons? 3. 3 with probe. Between carbon and carbon, single atoms are there. Single carbon bond is there. So we can say that cyclopropane. Cyclopropane. Similarly, cyclopentane. Similarly, cyclohexane. Similarly, cycloheptane. So one more example for cyclic hydrocarbons, cyclic hydrocarbons. Hexane is hexane. Hex means 6 carbon atoms. 1, 2, 3, 4, 5, 6. So 1, right? 1, 2, 3, 4, 5, 6. Hexa. So cyclohexane. Where is it? 1, 2. So then here we can write hydrogen, then hydrogen. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So here we get like this. Cyclohexane. Cyclohexane. The cyclohexane is formed by the single covalent bonds between the carbon and the carbon atom by sharing the electrons. So electron dot structure of cyclohexane has been obtained by putting 2 electron dots in place of every single bond. Every single bond. So here we can write the cyclic structure. So by writing Lewis electron dot structure, 1, 2, 3, 4, 5, 6. Hydrogen, hydrogen, hydrogen. So here also hydrogen, 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 hydrogen. So every single bond is represented with 2 dots. The 2 dots are indicates electrons. Electrons are shared. Electrons are sharing. Electrons are sharing. So this is electron dot structure. So carbon, 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 4, 5, 1, 2, 3, 4, 5, 6. So between these carbon and these carbon, electrons share. Between these carbon, electrons share. Between these carbon, electrons share. These carbon, electrons share. Electrons share. This is single bond, single bond, single bond like that. Then with hydrogen, with hydrogen. Here with hydrogen, 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 with hydrogen. Right? So CH2, 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 CH2. So we can write hexane, cyclohexane like this: CH2, 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 CH1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. CH. So that's our mission. 1, 2, 3, 4, 5, 6. This is cyclohexane. Cyclohexane. Like that, we can write cyclopropane, cyclobutane, cyclopentane, cycloheptane, cyclooctane, like that we can write. So this is an example for saturated cyclic hydrocarbons. Saturated cyclic hydrocarbon, unsaturated cyclic hydrocarbon, unsaturated cyclic hydrocarbons. Right? So unsaturated cyclic hydrocarbon, between carbon and carbon there is unsaturation. At least one single bond, one double bond or one triple bond is present between the carbon and carbon atoms. So such carbon, such hydrocarbons are called as unsaturated hydrocarbons. So for example, 3 carbons are there. Pro. If between these 2 carbons has double bond. If we double bond, we can write pro plus E, propene, right? Then 1, 2, 3. Here H bond. 1, 2, 3. Here H bond. 1, 2. Here hydrogen and hydrogen. Saturation number is. Where is satisfaction? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3 with hydrogen 4. So cyclic. You can write as cyclopropene. Cyclopropene. If it is any triple bond, then cyclopropane. Cyclopropane. So then one more example for unsaturated cyclic hydrocarbons. Unsaturated cyclic hydrocarbons. Unsaturated cyclic hydrocarbons are benzene is another formula is benzene. Benzene is the example for unsaturated hydrocarbons. Unsaturated hydrocarbons. Little confusion, just wait. Okay, then benzene formula, benzene C6H6. Benzene formula is C6H6. So 6 carbon atoms, 1, 2, 3, 4, 5, 6. So here in benzene alternatively there is a double bond between the two carbon atoms. Between the two carbon atoms there is a double bond. There is a double bond is present. So this is an example for unsaturated hydrocarbons. So saturation 1, 2, 3, here 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So benzene is an example for saturated and unsaturated cyclic hydrocarbons. So between the carbon and carbon atom, if you have at least one double bond or one triple bond, one double bond or triple bond, such hydrocarbons are called as unsaturated hydrocarbons, and these are the examples. So cyclic, ringed, closed structures. This is about the cyclic hydrocarbons. Cyclic hydrocarbons. So this is cyclopropene. Then cyclobutene, cyclohexane, cyclopentene, like that. So present. If a triple bond is present between, for example, carbon 1, 2, 3, 4. Between any of these two components with triple bond is there. Right? 1, 2, 3, 4 satisfied. 1, 2, 3, 4 satisfied. Here 1, 2. So here hydrogen and here also hydrogen. Hydrogen. So 1, 2, 3, 4. 1, 2, 3, 4. So 1, 2, 3, 4. 1, 2, 3, 4. So this is cyclobutane because of triple bond is present. So like that we can write cyclic hydrocarbons and their structures. Right. Then next one, some topic regarding to coal and petroleum is given. So coal and petroleum you already learnt in class 8th. So formation of coal and the formation of petroleum you already discussed in the class 8th. So because coal mainly consists of carbon. Coal mainly consists of carbon, whereas petroleum consists of hydrocarbons. So coal was obtained very long years ago, about 300 million years ago. It has densified. Then due to some natural disasters, the trees fell down on the ground, So due to the deposition of sand, debris, soil, so more and more they sink deeper into deeper, and due to the absence of air, rise in temperature and pressure, the dead vegetation is converted into coal. So that process is called as carbonization. That process is called as carbonization. Then, so when a fuel is burnt, when a carbon, when wood is burnt, then what will happen? It produces a carbon dioxide, heat and light. Most of the fuels which are using today, because these coal and petroleum and their products are used as a fuel for many purposes. So when the fuels are burned, then they release carbon dioxide. And heat and energy. So already we discussed how was the coal is formed, right? How was the coal is formed over long years ago due to the decomposition of dead vegetation. So the process is called as a carbonization, right? Then what about the petroleum? Petroleum is also formed very long years ago. There are some small living organisms which are lives in the seas and oceans. They are called planktons. So they die and they have a little drop of oil inside their body. So they sink deeper and reach the bottom of the seas and ocean. So some soil debris are deposited due to the absence of air. As usual, temperature and pressure increases. Then it converts into crude oil or the oil along with some natural gas also after. So as we already discussed, you learned about coal and petroleum. So no need to discuss much about it. But most important thing is coal consists of carbon, most of the percent, then other percentage hydrogen, oxygen, nitrogen also present as impurities. Then petroleum consists of hydrocarbons. So they has the ability to produce heat while they are burning. So that's why these are used as a fuels. They are used as a fuels, right? Why do substances burn with a flame or without a flame? So in classic chapter combustion and flame we discussed. So when does or how does a fuel or how does a compound or a material burns with flame and burns without flame? So mostly gases are burns with flame because of they are already in the vapor state, and but coming to the solids and liquids, so they cannot means liquids also burns with flame because of on heating. So they vaporize it quickly. Then the vaporized molecules of fuels catches the fire and burns with the flame. But coming to the solid fuels like coal, charcoal, like coal. So these are the solid fuels. They cannot vaporize in the they cannot vaporize, so they cannot burn with the flame. They burn but cannot form any flame. So just they burns with red hot. So LPG burns with blue flame because of complete combustion. Of the fuel. So what is meant by combustion? Combustion means the chemical process. Combustion means the chemical process in which a material reacts with oxygen present in the air, produce heat and energy. So the chemical process is the chemical process in which a material or a substance reacts or combined with oxygen, produce heat heat energy and we also light energy. So we know blue flame and yellow flame. Blue flame is formed by the fuel where the complete combustion takes place, means due to the sufficient supply of oxygen, due to the completely burning of particles of a fuel, then a substance of the fuel burns with the blue flame. Some cases, sometimes we observe some of the materials are burns with yellow flame because of incomplete combustion. Because of incomplete combustion, this incomplete combustion takes place due to the insufficient supply of oxygen or incomplete burning of particles of substance of the fuel. Right? So those solid and liquid fuel do not vaporize on heating, burns without producing flame. So when the oxygen supply is insufficient, then already we discussed all those. So due to the insufficient supply of oxygen, incomplete combustion takes place. Due to this incomplete combustion, a substance of the fuel burns with yellow flame. So due to the sufficient supply of oxygen, particles of fuel of the substance burns completely and produce blue flame. So we already discussed, there no need to discuss much about this because the class 8 already you learned different zones of flame. So blue zone, black zone, outermost zone, innermost zone, whatever. So that's why here I did not explain much about this. So this is about our first session. We discussed cyclic hydrocarbons, unsaturated cyclic hydrocarbons and saturated cyclic hydrocarbons until the discussion about coal and petroleum. Right? Thank you.